Now that we've learned a lot about our ionic compounds, we're going to shift gears now into looking at covalent compounds. Now, we've learned a lot about the difference between ionic versus covalent compounds, and we first focused on ionic bonding nomenclature. Now we're going to shift into covalent compound nomenclature. Let's go and take a look at what we have here. There's a couple things that's worth noting. Don't forget that covalently bonded compounds, these are groups of nonmetals all bonded to each other. Right? And nonmetals, of course, come from a very specific part of the periodic table, so please make sure you review where those are. Now, when we talk about covalent compounds, there's several types. We're going to start off with binary covalent. Right? Binary covalent. So binary covalent refers to a compound where it's covalently bonded, so that means two nonmetal elements, but also the fact that two, right, refers to binary. So binary and two always go hand in hand, but specifically two elements, not just two atoms. So these prefixes that I may have mentioned before, those prefixes, meaning mono, di, tri, these are very much so in effect here. So heavily relies on these Latin prefixes, which we'll talk about in the next slide. And of course, in a quick comparison versus ionic compounds, these rely on combining charges of ions, right? So these ionic compounds, they do have these ions that we care about, and we need to know about combining the charges, so that's overall neutral. And the ionic compounds do not rely on Latin prefixes. So notice how covalent compounds don't apply to either of these. Covalent compounds don't have any ions we're dealing with. Covalent compounds do rely on Latin prefix, where ionic compounds did not. So this slide right here breaks down the 10 that I want you to know. Most of these should be fairly familiar, but make sure you commit these to memory because this is vital to knowing how to write out these next compounds. Binary covalent nomenclature is fairly straightforward. Binary covalent nomenclature effectively is, again, kind of what you see is what you get. Right? So if you look at the beginning here, the name going to a formula. You know there's Latin prefixes that we mentioned. Definitely use the Latin prefixes to identify the number of atoms, which also refers to the subscript of those elements that are involved. Right. The only exception to this, again, using those mono, di, tri prefixes, I mean, using any of those, there's one quick exception, is that the first element does not receive that mono prefix. So that in that case, right, whenever you see certain elements written or certain compounds written out, we don't include mono for the first element. But everything else, right, every other situation gets the prefix. The second element that's involved, the ending changes to an "-ide" ending. So kind of what we saw before, the "-ide" ending shows up again. This could potentially be a source of confusion if you're not careful. For now, though, just recognize that we do have an "-ide." We'll talk about how that confusion can set in later. We also have formula going to a name, and this one again is very much literal. What you see is what you write. So we're going to translate whatever subscripts we see on a formula, and then we're going to change it to the Latin prefix that go with it. There's a little bit of a nuance here in terms of how you write it out. So if you have an O or an A at the end of a Latin prefix, for example, mono, right, that's an O at the end of the prefix. If you have an O or an A at the end of a Latin prefix, the next element, or whenever you talk about the next element, if it starts with another vowel, we usually drop it. So for example, penta, right, P-N-T-A, that refers to 5. Penta ends in A. And if you're talking about having an element afterwards, which has a vowel like O for oxide, actually we don't write pentaoxide, we instead write pentoxide, right? Pentoxide. So we drop the A here and make it pentoxide. Or for monooxide, right? Mono ends in O. Oxide, monoxide becomes, monooxide really should be written as monoxide. And then as the third example here, this is a non-example of what we're talking about here, about the drop-in letter. So tri, right, tri meaning 3, but that prefix ends in an I, not an O, not an A, so it's I. And the next element is iodide, so this would actually be called triiodide. Right, triiodide. You wouldn't actually separate this and make this, or you wouldn't actually drop an I and make it triodide. It would be triiodide with very distinctive syllables there. So let's go and take a look at a couple of examples. I'll do one or two of them with you, and I'll let you try the others on your own. Now let's do the first one, SO2. SO2, first of all, how do we know what kind of compound this is? Well, this is a binary covalent compound. How do we know that? Sulfur is a nonmetal, oxygen is a nonmetal, and there's only 2 elements involved. So it's important to make that distinction first, ladies, if you have not been doing so. So this is a binary covalent. There's the little BC next to it. So binary covalent. That means we're going to basically write whatever we see down and translate it with a couple of small changes in the nuance. So this ends up being sulfur right? That's your first element. Notice how I don't have a prefix because this is the first element, even though there's only one, right? It's not monosulfur. We just write sulfur. And then the second one would be dioxide, right? So oxygen becomes an ide, dioxide, sulfur dioxide. The fourth one, let's skip down here, going from a name to a formula. This is disulfur decafluoride. So notice how, again, how do we know that this is a binary covalent compound? We know it because it's got the element sulfur with some prefix. It's got the nonmetal fluoride with a prefix and also the IDE ending. So all that together points to being a binary covalent compound. So we have to translate this, and knowing the formula for this is going to require you to translate the prefixes into numbers. So disulfur, well, di, it means 2, so S2. And then fluoride, that's going to be the element F with deca, that's the prefix for 10. So S2F10, disulfur decafluoride. Go and try the rest of these examples out to make sure you understand how binary covalent problems work. So in this next section here, some more practice, giving you an opportunity to identify some common errors. Go and take a look at the prompt to make sure you understand what it's asking you for, and then give these a shot as well. In this section, got a little bit of mixed practice here. This is one where we've at least talked about a lot of different types of compounds. You can see right here on the right side, there's a bunch of different categories here that we've discussed already. And so what I'm giving you here again is an opportunity to add one more type to make sure you can distinguish the difference between each of them. All those different processes we've talked about, changing it from one form to another. All these little things are important to recognize. So on the left side, we see right here, I want you to identify the specific type of compound, so whatever we've done. It'd also be helpful to identify, the little metals, if they're monovalent or multivalent, and then, of course, provide the corresponding name or formula as you would be asked to do. So I cannot stress enough how important it is that you do take the time to identify the type of compound and the features that are important to address, and then attempt. Right? So don't try attempting without looking or thinking about the type of compound it is. Finally, I'm going to go ahead and give you 4 compounds that I want you to recognize. These 4 are all covalent compounds. These are, in fact, binary covalent compounds that I want you to know, because these are ones that are very commonly discussed, and so it's useful to have these in the back of your head to know what their formulas are. Alrighty, that'll do it.